Back. This is lecture 6, while loops and defining functions. This covers sections 5.1, 5.2 and 5.4 from our textbook. The while loop is a control structure which is used when a programmer needs greater flexibility than is offered by the for loop. Remember, we went through for loop recently in our previous lecture. For loop, you have a fixed length. You know precisely what list or tuple or string you're going to go over, okay? Or in this earlier case, there is a range. You know precisely which numbers you're going to use in a for loop. So a for loop works well if you know before you code how many times you are going to go over that loop. Okay, but sometimes you don't know that. That's when a while loop is important. You don't know how many times you are going to go over a loop. All right, that's one way of distinguishing. So while loop offers far greater flexibility. The for loop requires a pre-existing sequence of objects. The while loop is used when such a sequence is not available in advance. So if you remember for the for loop, you go over a list or a tuple or a string, but these things have to be known beforehand. While loop is used when such an option is not available. The general syntax for the while loop is while a condition colon body of the loop goes indented. Okay, so while the given condition is true, you will implement the body of the loop. The moment it is false, you get out of the loop. Okay, for example, in an interactive game, we could have the following code: response, input is the command which allows you to get input from the user. Shall we play a game? Space, input. So response will be either a yes or a y. While response dot lower in y or yes, you do something. Play a game. Response, ask again. You have finished playing a game, ask again. Do you see what's going on? You probably have seen many games, online games, where you finish the game and at the end the program asks you, would you like to play the game again? Either you say why or yes, and then you start a new game. This is how it's achieved. First ask for an input. If it is a yes or a why, you start the game. After finishing the game, you ask again. You understand? So here is the flow chart for it. You have a condition. You have come down from the program somewhere. There is a condition. If the condition is true, the body is implemented. And once it's completed, you go around and ask the condition again. When it's not true, when the condition is false, that's when you exit the loop. Okay, so here is the Euler's algorithm to find GCD of two positive integers. U is int input. So notice when you ask your user for an input, whatever the user gives you is in the form of a string. You have to convert it to an integer to get you a U. V, in the same fashion, you get a second positive integer. Convert it to an int, assign it to V. Your guess is minimum U and V. While U percentage guess, what does that mean? That means the remainder when U is divided by guess, is greater than 0. That is, you don't have remainder 0. That means guess does not divide u evenly, or guess does not divide v evenly. Then decrease guess. Well, at any point, guess divides u evenly, in which case you get percentage to be 0, modulo to be 0. When guess divides u and v evenly, you will get this 0, this 0. So both, you see, will not be satisfied. So the condition is false. That's when you get out of the loop and the GCD is guess. All right. So let's play with this a little bit. Let me write it down, a few things, right? Input, this is a new function you are seeing right now. So let's say, suppose u equals input, enter a number. Suppose you want to try it. I leave no space. So look at how it's written. Quotes, enter a number, no space over there, close quotes, close parenthesis, input. You see how my cursor is just next to R. If I write 34, it is not very readable, though it works. Notice how U is a string of 34. So let's improve this way of writing. Input, enter a number, colon, 2 spaces, 1 space, but at least 1 space. When you do this, enter a number, colon, there is space. Now this is more readable for the user. If I give 34, that's good. What is U? U is still a string. Okay? So if I want number, then I will have to say int input, enter a number, colon, space, space, close one parenthesis, close the other parenthesis also. Enter a number, 34. Now let me look at U. U is now a pure int. Okay? If I want V equals int, not int, suppose I wanted a float. Input, enter a real number. Okay? So notice that space makes things readable. So say 34.56. What is V? V is 34.56. It's no longer a string. If you did not have a float, V would be just a string. Okay, check for yourself. So that is the input. Okay, you can have several things, right? Input, please enter your name. Okay, so it's asking me, please enter your name. So John. What is name? It's John. Okay, so this is how you interact with the user. All right, so now let's write the GCD. Find the GCD. If you don't remember this, this is not the Euclid's algorithm. This is the very first GCD algorithm we had. So let me remind you where it was. It was on page 2 or 3 of our lecture notes. There you go. So you start with a guess equal to the smaller number. Let me bring this to 4. You will see what's happening. Guess is minimum of U and V. If my guess evenly divide both values, then my guess is the GCD. When the guess evenly divides both values, GCD is the guess. Okay? Otherwise, I have to reduce the guess by 1 and I keep going. That's exactly what this is doing. So percentage, if you remember, means modulo. If u modulo guess is greater than 0, or v modulo guess is greater than 0, that is, guess either does not divide u evenly or guess does not divide v evenly, in which case we have to continue. Guess cannot be the GCD. It does not divide one of them evenly. So let's implement this. Look, there are many lines of code here. So it makes no sense to write it in a shell. We have to produce a new file. So how do, let me remind you, you're on a shell, go to file, new file. It gives you a blank page. And this is where we will start our GCD program algorithm 1, correct? So this is GCD 1, right? So that's the name of my program, okay? So that was a small introduction. Now let's start with the program. U equals int input, enter first positive integer, v equals int input, enter second positive integer, let the guess be minimum of u and v, while u percentage guess is greater than 0, or v percentage guess is greater than 0, colon. So that is my while condition, decrease guess by 1, guess minus equal 1. So this is same as guess equals guess minus 1. So instead of writing all of this, you say guess minus equals 1. So go through this while loop, and when you find your GCD, you have to print the GCD is, comma gives me a space, the guess at present. Now, once you have typed everything in, don't forget to save. What's the matter? Yeah. Save as. So this is lecture 6. So I don't want to save it here. I want to save it not in lecture 5, lecture 6. Okay. So let's save it as GCD1, and it's going to be an automatically PY. Okay. So now we have saved it, we can run it, enter first positive integer. Say I give it 36. Second positive integer, 50. The GCD is 2. All right. So the program, you can keep trying. Run it again. Try another number, 78, 132. GCD is 6. All right. So I don't like the fact that I have a sentence here and no full stop here, period, right? So I will say comma, period. Okay, this is not ideal. Let's see what happens here. Okay, so 80, 55, GCD is 5. Do you see a space there? I don't like that. So what would I do? Well, I can do the following. Guess is at present an integer. Let me make it into a string, right? And concatenate the character with the full stop. Now let's play with this. Okay, first positive integer 100, second positive integer 234. There, the full stop is good.